In this video, we will be discussing Western blotting, a widely used biomolecular technique for detecting proteins in samples. Vortex the samples and then incubate them at 95 degrees Celsius in a heating block for 5 minutes to denature the proteins. The protein ladder does not need to be incubated. Dilute the 20x MOPS running buffer to a 1x concentration with deionized water. Remove Bolt Bis Tris Plus gel from the package, remove the comb from the wells and take off the strip from the back of the gel. Wash out the wells with running buffer. Add gel to the mini gel tank and then fill with running buffer. Load 10 microliters of protein ladder into the first lane. Load equal volumes of your normalized protein samples into the appropriate wells. Always load the samples into the middle of the gel. Place the lid on the mini gel tank and hook it up to the electrophoresis power supply. Set the voltage to 190 and run the gel for 35 minutes until the dye front reaches the end of the gel. For each gel, cut out a sheet of nitrocellulose membrane that is the same size as the gel. Cut the top left corner off the membrane to help with the membrane orientation after transfer. For each gel, soak 1 membrane and 4 filter papers in transfer buffer. When the dye front has reached the bottom of the gel, turn off the power supply and open the gel casing using a spatula. Wet the gel with transfer buffer, trim off the edges of the gel and cut off the top left corner of the gel. Using the spatula dipped in transfer buffer, transfer the gel to a shallow container filled with transfer buffer. Agitate the gel for a few seconds. Place 1 fibre pad on the black side of the transfer cassette and place 2 pre-soaked filter papers on top of this. Next, gently transfer the gel onto the filter papers, keeping the top left corner in right orientation. Place nitrocellulose membrane on top of the gel and roll with the roller to remove any air bubbles. On this, place 2 more filter papers and lastly, the second fibre pad. Close the cassette and place in the tank with transfer buffer and an ice pack. Run the transfer at 100 volts for 45 minutes. When complete, turn off the power supply, remove the membrane and wash in deionized water. The membrane will now have a different orientation and the cut should be at the top right hand corner. Decant and wash once more. Decant the water and add Ponceau S stain for 3 to 5 minutes to assure appropriate transfer and equal protein loading. Wash off the Ponceau S stain with deionized water. Ensure that the Ponceau is washed off appropriately as this can affect your final reading. Cut the membrane to size and incubate in blocking solution, which is 5% BSA in TBST, on a rocker for 1 hour at 4 degrees Celsius. Here, we placed it in the cold room. Remove the blocking solution and incubate the membrane with an appropriate primary antibody on a rocker for 15 to 48 hours at 4 degrees Celsius. Remove your primary antibody and wash the blots in TBST for 8 to 10 minutes. Repeat this 5 times. Add the appropriate secondary HRP-linked antibody for 1 hour at room temperature while rocking. Remove your secondary antibody and wash the blots in TBST for 5 to 8 minutes. Repeat this 5 times. Prepare the HRP substrate solution and protect it from light. Clean the loading tray of the Amersham imager prior to use. Pat dry the blot and add approximately 1 ml of the HRP substrate solution to the blot and incubate for 1 minute. Remove excess HRP solution and place the blot on the loading tray. Load the tray into the Amersham imager in the upper position. Auto-expose the membrane on the chemiluminescent channel.